Let's see.
All right, we should be recording now.
Awesome. Okay, then. So I am pleased to introduce an esteemed guest speaker who will be talking to the UTEP community about insights into not just Sandia National Laboratories, but also the American Institute of Aeronautics and Astronautics. Dr. Hassan is a native of Raleigh, North Carolina, has his bachelor's, master's, and doctorate from North Carolina State University in 1993. He is currently the director of the Chief Research Office and serves as Sandia's Deputy Chief Research Officer. In his role, Dr. Hassan leads Sandia's research strategy development, including the execution of the Laboratory Directed Research and Development Program, the LDRD, and oversees Sandia's external partnerships and technology transfer programs. Dr. Hassan has been employed at Sandia since 1993 and has managed all phases of research, development, and applications. His work has predominantly been on thermal, fluid, and aeroscience technologies, helping Sandia to accomplish its national security mission, which of course is very important. And also, Dr. Hassan is a fellow at the American Institute of Aeronautics and Astronautics and serves as the Institute's president for 2020 to 2022. And previously, he has been the vice president and is on the board of directors. So with that said, Dr. Hassan, I'd like to hand it over to you.
Okay. Well, I want to thank you all for having me today. As Eric said, I'm going to try to talk on two topics today. First, I'll sort of give you an introduction to Sandia and talk about some of the aerospace related work we do. I'll pause for questions on Sandia, and then after that, I have a short presentation on AIAA. So let me go ahead and get. Well, I'm really honored by the number of folks on today. So thank you. So let me get the first presentation shared. Once I go to full screen, I won't be able to see anybody. So just let me know that it's up okay.
Yes, we can see it. Okay.
All right. So once again, thank you. I want to talk a little bit about Sandia. So Sandia was actually founded in 1949. We actually started as part of the Manhattan Project when Los Alamos was created, which ultimately developed the two nuclear bombs that were used to end World War II, at least in the Pacific. And we were officially started as a national laboratory in 1949, when then President Harry S. Truman sent a letter to AT&T Bell Labs and asked them to render exceptional service in the national interest, our motto, by running this laboratory. And so we are what is called an FFRDC, or Federally Funded Research and Development Center. We are run for the Department of Energy by the National Technology and Engineering Solutions of Sandia. This is basically a Honeywell subsidiary. Prior to Honeywell, we were run by Lockheed Martin for almost 25 years. So let's see, a little bit more about Sandia. So Sandia, being a national laboratory, means we're an asset to the nation. And oftentimes we are called on to support various, what I call national disasters or important areas. So just in the last few months, we've been supporting the COVID-19 pandemic and trying to figure out ways of better understanding the disease, as well as coming up with things like turning CPAP machines into respirators for the hospitals, the local hospitals, and things like that. And so we've invested some of our research funding there. Sandia was actually the inventor of the first modern day clean room. We have supported a lot of different areas, including 9/11. We supported the Columbia Space Shuttle accident investigation, which I personally got to help support. I'll talk about that later. The Deepwater Horizon oil spill, the Japanese Fukushima nuclear reactor shutdown, a lot of different areas. And so we'll talk some more about some of how Sandia focuses their efforts. So we have two main locations, the first one being here in Albuquerque, New Mexico. That's where about 85% of our 13,000 employees reside. And then we've got a smaller site in Livermore, California, which is right across the street from Lawrence Livermore National Lab. So Sandia is the engineering arm of the nation's nuclear deterrent work, and we work very closely with Los Alamos and Lawrence Livermore. Our funding is nearly $4 billion, and about 60% of that comes from what we call the NNSA, or the National Nuclear Security Agency or Administration. And that's basically a semi-autonomous agency that sits under the Department of Energy that's focused on making sure that the nuclear deterrent is safe, secure, and reliable. And we'll talk more about that in a couple of slides. About a third of our funding comes from what we call strategic partnership programs. And these are basically other government agencies that are sort of in the national security arena. So the Department of Defense, the intelligence community, Department of Homeland Security, and various National Institute for Health, and various other institutions. And then about 8% of what we do is sort of the classic Department of Energy. So that's things like renewable energies and other nuclear energy work. So I'm going to quickly go through this slide, then I'll talk a little bit more about each. But we basically break up our work for doing our national security work into what we call mission areas. So our largest mission area is in nuclear deterrence. Is everyone still there?
Yes, sorry. When they enter through the phone, it announces it sometimes.
Okay, no problems. And so our mission here is to ensure that the U.S. nuclear arsenal is safe, secure, and reliable, and can fully support our deterrence policy. So the deterrence policy is that we don't want to use our nuclear weapons because we've seen what they can do, but by us having them, we sort of use them as a deterrent for other nations who want to develop them to actually use them. And so that's a policy that we've had around for many, many decades. And it seems to work, but of course, you know, you do have what we call rogue nations who would like to develop nuclear capabilities. Global security. So this is a lot of work that we do to help monitor and understand some of the dangers around nuclear material, countries that might have it and how they might use it, and are they protecting it and things like that. And so monitoring and understanding, you know, if other nations are trying to develop that capability is important. We have national security programs. This is primarily a lot of the work that we do for the Department of Defense, as well as, you know, the intelligence community. Energy and Homeland Security. So this is sort of looking at the nation's critical infrastructure for our electric grid, our, you know, water and wind energy and power and things like that, as well as making sure that we're not vulnerable to other chem, bio, or nuclear attacks. And then finally, advanced science and technology. And this is basically our core programs, our core research programs, which I sort of liken to a college of engineering. So let's go into a little more detail. So the nuclear deterrence work is really important. I liken it to the human spaceflight program, because we have to make sure that these systems only work when we intend them to. Luckily, we haven't had to since World War II, and then never work when we don't want them to. So a lot of the engineering work that we do at Sandia is not only ensuring that these systems can operate, but we can make sure that they're safe, secure, and reliable. And the fact that they've been around a number of years, make sure that they will work as intended. National security programs, again, is supporting a lot of the defense capabilities. And so an example of it is we deploy a lot of sensors and capabilities on satellites or on UAVs. And one of them is something we call synthetic aperture radar, or SAR. And this is an image of Dodger Stadium, I believe, taken on a cloudy day. So the imaging capability can see through clouds. And the one thing it does is it gets very fine detail. So if this had been a picture taken before a game at Dodger Stadium, and then they took a picture the day after, you would actually see all the tracks of where the players had run on the grass. It's that sensitive. And this was actually used in the Gulf War to look for improvised explosive devices, because we could see, for example, where somebody might have dug a hole in the road and buried one of these devices, these dirty bombs, and then tried to cover it back up with dirt, or we could see, you know, people walking or Jeep tracks to certain areas, and that helped us avoid some of these things and neutralize them. Our energy programs, we're really interested in things like renewable energy, so wind energy, water power, solar energy, clean nuclear energy, and just making sure that our infrastructure is secure. So we're very lucky in this country to not have very many power outages. When we do, they're usually very few and far between. And so making sure that someone could not attack us by trying to take out our infrastructure is another important area. Global security, this is an area that we call sort of defense nuclear non-proliferation. So when the Cold War ended in the early 90s, we were really worried about the breakup of the Soviet Union, in particular because many of the former Soviet republics had a lot of their nuclear capability, Russia's nuclear capability, in the border countries. And we were worried about the nuclear material or the nuclear farming systems and things like that falling into the hands of other countries who are trying to develop nuclear capability. So we worked very closely not only to develop monitoring capabilities from satellites or UAVs or seismic detectors to determine if somebody was actually trying to set off or test a nuclear weapon. And then finally, the area which I'm most familiar with is our advanced science and technology area. And these areas that you see here are what we call research foundations. So engineering sciences, that's your classic thermal, fluid, structural, electrical analysis areas. Computing and information sciences, we develop a lot of computing algorithms to run on the fastest computers, including some that have been housed at Sandia. Radiation and high energy density science. So we have to worry about our systems and our components and our materials being able to withstand very high or what we call extreme environments, so high radiation environments or high temperature environments. And so we've got capabilities like nuclear reactors and things like that we operate. Material science is very important because everything is made out of something, and trying to understand the properties of materials and how they might react in these very extreme environments are important. And then more recently, we've been involved in microsystems and nanotechnology as well as bioscience. And it's a good thing we invested in the biosciences area, because that's actually been an area where we've been able to contribute due to the pandemic. So we've also got a lot of really cool facilities that we get to steward for the nation, including a combustion research facility out in California, which is an open user facility that we actually work with the engine manufacturers and the car companies to try to help develop and understand, you know, highly efficient, clean burning combustion. We've got environmental test facilities. This is a picture of a sled track, and it's a unit that's being propelled down the sled track in order to impact it into a concrete wall so we can understand those impacts. We've got a nuclear reactor, we've got large computers, we've got our own microelectronics fabrication facility where we developed some of the most important radiation hardened microelectronics, which can be used in nuclear applications as well as space applications. And then we've got our Center for Nanotechnology. So I want to talk a little bit about some of our aerospace capabilities. And one area that Sandia has been extremely active in the last few decades is hypersonics. And hypersonics is one of those areas that has tended to come and go, but I think we're actually in a boom cycle right now. And Sandia has been an important player because we have continued to maintain capability in hypersonics. So we do everything from developing computational techniques that help us understand when that boundary layer goes from laminar to turbulent flow. We try to understand how the reentry vehicles and the components on the inside might vibrate due to the unsteady shock waves or to the turbulent flow. We've developed capabilities like direct simulation Monte Carlo methods to compute very high altitude aerodynamics, where the air can no longer be considered a continuum. And then we develop experimental techniques as well to help us validate these numerical models and help us better understand the physics of hypersonics, which is very hard. So a few examples. So one of the areas which I was involved in years ago, but people are continuing to work on, is trying to understand ablation of reentry vehicles. So if you think about some of the ballistic missiles that have these very sharp noses, or even the Apollo-like vehicles, or the SpaceX vehicles that recently flew, they fly fast enough that the heat flux into the material is so high that the material can't maintain its shape. And so what we do is we use this process of ablation to actually let material come off the body, and when it comes off, it actually helps manage the heat into the vehicle. So the way you do it is you put more material than you think you'll need, you'll allow for some of it to come off, and it helps manage the heat. So this is an example in blue here, is just a generic nose tip flying at hypersonic speeds. And then this is the shock wave that's out in front of the vehicle, and then you can see the high temperature flow behind it. And when I play this movie, this is going to simulate this vehicle coming in on a particular trajectory, and you'll actually start to see that this nose tip will start to recede and move from left to right. And that is mimicking the process of ablation, where the material is actually being moved. And you can see the shock shape get closer to the body, and then you can actually see over time the vehicle change shape. So why is ablation important? Well, we'll talk about that later when I talk about some of the work I did in graduate school. We also do a lot of flight testing and flight research, and this is an example of a hypersonic reentry vehicle, a maneuvering one that this is sort of an artist rendition of one that we flew for the Department of Defense as part of this resurgence in hypersonic programs. And so we actually have a launch facility out in Kauai, and this is an example of a rocket that we modified to fly these vehicles. So most of these rockets, this was actually a former rocket that came out of a sub. They fly very, very high altitude. So they go up straight, they tilt over, and they go up for millions of feet. Well, we modified this rocket so it will actually turn over and fly horizontally, so we could get as much hypersonic velocity for this vehicle as possible. And in order to do that, we had to put these things here at the bottom of the rocket called grid fins, and those were put on to help the rocket be stable as it was flying at lower altitude. And that was the first for a US rocket. The Russians had done this before, but this was the first time for the US. And then we also develop experimental diagnostic techniques. So if we're going to develop these computational models that we're going to run for hypersonic flows, we need to be able to understand the physics of the flow field and things like that. And so if you've ever been in a wind tunnel and see a probe, anytime you stick a probe in the flow field, then you're actually changing what the flow field looks like. So we've developed what we call non-intrusive diagnostics, or laser-based diagnostics, where we don't actually have to put probes in the flow. And one of them is called particle image velocimetry. And the way PIV works is you upstream of your model in the wind tunnel, or you see these very, very micron-sized particles, almost a cloud of these small particles in the flow. And then you use these lasers, and this green sheet here is a laser sheet with high-speed cameras that are outside the wind tunnel looking through a window. And you basically measure the movement of those particles, and then you can get velocities from that, because you know position and distance, so that can give you velocity, and you know time. And so the way PIV works is, and this is an example of a flow across going from right to left across this fin, and then you're generating vortical structures behind the fin. So you get a horseshoe vortex that's generated around the fin, and then off the tip you actually get vortex flow. So these images, and here's a larger one here, this looks like a simulation from computational fluid dynamics, but it's actually not. It's actually a measurement of velocity, and you can see the little velocity vectors here showing the vortical flow. And so the great thing about this stuff is we can get sort of one-to-one comparisons of what we can measure and then what we can compute. And then we can better understand vortical flow or turbulent flows or things like that. It helps us validate the codes we have. This is another example that we used where this is an example of I think this is the F-35, and this is an example of these bomb bays opening, and they want to understand the flow field that takes place in here, so when that bomb drops, it drops cleanly. And what you can happen when you open up these bomb bays, you get what we call an open cavity. And so down here at the bottom is sort of a cartoon of flow going from left to right over this open area. And then you get a shear layer that develops, and we were really interested in understanding the acoustical loading on the weapon bay to make sure that we weren't going to create some structural response that would cause problems. And so what we did is we used our PIV data capability to understand the flow field in and around this cavity. So again, flow from left to right, and I'm going to play this movie, and you can actually see this unsteady shear layer that develops and all the turbulent flow. And what happens is you get flow that's impacting this wall, and then we can measure the acoustic response by putting in high frequency pressure sensors and things like that. And so we actually did simulations to validate our codes to simulate this bomb bay situation before we ever had any flight data, and it helped them actually qualify the system that was going to go in there before they ever flew it in flight, and they could understand, you know, the fluid environment as well as the structural and acoustic environment that this vehicle was going to see. So really cool stuff. And again, this helps us validate those computational models because turbulence is still really hard. We have no closed form solutions for turbulence. Okay, so let's get past that. So that was just an example of some of the work we do. I could probably spend all evening talking about this stuff, but I just wanted to give you some highlights. One of the things that we're very interested too is recruiting from universities, and El Paso being very close to Sandia, it'll be really great if we can get folks coming up for internships or postdocs or regular jobs. And so what I'd encourage you to do is go to sandia.gov/careers. And I think we're trying to get some of our recruiting folks to maybe do a virtual career fair with you all maybe next semester. But I'd encourage you to go ahead and apply, and you can look at various disciplines. You can go on the website and create a profile, and then you can sign up for an automated job notifications given keywords. So if some of you are looking for an internship, I usually just tell people, put in the word intern as your keyword, and anytime an intern job comes up, you'll get an email. Now, this past summer, all of our internships were virtual, and I'm guessing it's probably going to be the same for next summer, depending on what happens with the pandemic. But if we can get people to travel and come work with us, we will. We typically have about 1,300 to 1,400 interns on site or virtually on site in any one summer. So we get actually a lot of folks. So I'd encourage you, if you're interested, to log on our website and look for particular internships. And we have quite a few. So with that, I will stop this presentation. Sandia is a great place to work for. I've been here for 27 years, and I'll probably end up retiring here. Our motto, again, is exceptional service in the national interest. And one of the great things about the lab is you can come and work for one employer, but work in a lot of different areas over your career. So I'm going to go ahead and stop the presentation. And we'll see if you all have any questions you'd like to ask before I go on to the next part of the presentation. So I'll stop sharing and open it up.
So Myra, is there like a raise your hand feature in Teams that we should be employ, or how do you handle? Okay.
At the top of the screen, you should see the sign of a hand, a symbol. go ahead and mark that and we can answer your question. We will call on you to unmute yourself, or you can also type in your question in the chat. So right now we have Corey Marquez who has his hand raised. Go ahead, Corey.
You guys hear me?
Yep.
Yep.
Awesome. So, Dr. Zun, I had a quick question. So I know that like NASA and all aerospace industries are trying to incorporate, well, they do the usage of nuclear energy into space shuttles so they can, so the space shuttles can last longer. But I know that there's still some defects as like trying to make sure that the core temperature is kept at a cool.
Yeah.
So I was wondering if Sandia has any type of research opportunities there, or if you guys help out in that as well.
Yeah, so the types of spacecraft that use nuclear power right now are like the deep space probes, the ones that go to Jupiter and Saturn and beyond. And they have something called an RTG, which is a radioisotope thermal generator. And those provide power for those vehicles. And Sandia is actually involved because we do all the safety assessments before those vehicles are actually launched. And so we do have work that is in nuclear power. I don't know how much is going on in space nuclear power right now, but we have had people involved in that. Because at one time, they were actually talking about putting larger nuclear reactors up there to power multiple types of spacecraft, you know, including the ones that might go to Mars or Jupiter or beyond. The thing that probably inhibits them from using larger nuclear reactors is one is sort of the political piece of it, because people don't want us to launch a nuclear reactor and then have it come back and re-enter due to an accident. So that's why we do safety assessments. And then the other thing is that they're still working on making sure that any reactor that you put up there isn't going to damage the spacecraft or cause the people in the spacecraft to get exposure beyond what they would get out of normal space.
Yes, sir. Thank you.
Yeah, you're welcome.
Next, we have Alex de la Cruz.
Hello, doctor. Can you guys hear me?
Yes.
Okay. I have a few questions here. I know you spoke a little bit about internships and I guess like the positions you guys offer. I was looking into it a week ago, and my question is just about the internship itself. Like, I know there's multiple ones. Is it possible for us to apply for those multiple, or do we just have to focus on one as far as when applying to an internship for the summer?
No, I'd go ahead and apply to multiple ones if they're of interest to you. You know, we get hundreds or thousands of people that apply for all these internships. So I would suggest you pick the ones that you think might resonate with you and go ahead and put your name in for them and see which ones you get contacted.
Okay, and I have another quick question as well. For the internships as well, I know you said it's virtually. It might be virtually for the next summer. How did it work out as far as like as far as like a intern, as how, or I guess weekly or daily work would be measured or looked at, or how would we be working as far as like virtually?
Yeah, so you'd have a mentor, and depending on sort of your current level of education and interests, I mean, so for example, it's hard to do experimental work virtually. So a lot of those internships didn't happen, but at least the ones where, you know, we might have had people, you know, Sandia staff who may have taken some data and then they needed help in reducing that data and understanding it, or there might be computational codes that you'll learn and will be able to run and learn pretty quickly, and then be able to run on our computers and things like that. And so each of the interns would have sort of daily contact with their mentors, and they would sort of work through any problems that way. You know, it was a little bit harder. It was something new for us. The only time where we have typically had remote interns is when we've had, say, people come in the summer and then they go back to school and they might work a few hours a week on the work that they were doing, so they're already up to speed. So hopefully, keep your fingers crossed, we'll be able to bring people on site this summer. But if not, we do have options to try to have some meaningful work.
Okay. All right. Thank you, sir. I appreciate it.
Yeah.
Thank you, Alex. Next, we have Rene Aguilar.
Hello, Doctor. Can you hear me?
Yes.
Awesome. I wanted to ask, what are the procedures to ask to use or collaborate with one of the laboratories associated with Sandia? For example, the combustion research facility in California. How do we
So I
approach
would,
that?
yeah, I would Google the website. So I think the combustion research facility and our Center for Nano Technologies, which is here in Albuquerque, they're actually what we call user facilities. So they're actually, we actually have people who can write proposals and things like that to come in and do certain research with the folks at Sandia. The other way of collaborating with people is that we will, have professors who will get connected with some of our staff and actually do some joint research and things like that. So that's a good chunk of the people that we have are either graduate students or for doing the collaborative research, graduate students or postdocs. But again, some of our summer internships, we actually do have undergraduate students that get involved as well.
Thank you very much, sir.
You're welcome.
Thank you, Rene. Next, we have Arturo Rodriguez.
Okay.
Hello, Dr. Hassan. Since portability is gaining momentum through COCOS, do you think that the development of new ablation models is going to be ending? So you develop new ablation models because you can translate it to new computational architecture, like more powerful computational architectures?
Yeah, so there's more work to do in ablation modeling. I mean, the work that I started 20 years ago is still continuing. It's a coupled fluid, thermal, and structural problem, right? So you've got to be able to understand all the material properties. You've got to understand high temperatures. You've got to understand the materials, how they're going to react at high temperatures and things like that. So as long as we are flying spacecraft that would either re-enter into an atmosphere or like the NASA probes or the types of vehicles we deal with, ablation is always going to be a problem until we can find that magic material that doesn't need to ablate. And so I think that work will definitely continue. It's a very computational intensive calculation as well. So the advances that we're making in supercomputing and in some of the algorithms will definitely help us do some of those calculations quicker.
Thank you.
You're welcome.
Thank you, Arturo. Dr. Singh, you can go ahead and ask your question.
Sure. Hey, Dr. Hassan, excellent presentations. And then I have a couple of the quick questions. First of all, I assume that for the summer internship for the students need to have the U.S. citizenship, correct?
For the vast majority of the internships we have, that is correct.
Okay.
There may be some that are listed on the website that are in our open areas. So the areas where we might be able to, but I think actually U.S. citizenship is required now that I think about it.
Okay. And what about the security clearance? I mean, does they need to have that checking before they join the national lab?
Not necessarily. A lot of the work that we can offer them, especially the first summer, would be unclassified work. Okay. If we do put students in for a clearance, it's usually a low-level one, and sometimes those can actually be, if we make an offer to someone in the fall, sometimes the clearance will come in by the summer, but that's something we don't control. The government takes care of the clearances, so we usually plan for them not having a clearance the first summer.
Okay, thank you. And also another quick question is, my background is industrial engineering, mm-hmm. and then very different from the mechanical engineering. Yeah. And then for industrial engineering, in fact, our students are good at in optimizations, logistic, resource, allocation, and data analytic. I'm just curious, in the Sandia National Lab, in fact, I checked with the webpage, there is engineering sciences, computing, the information sciences. Those programs maybe kind of fit our student. I just want to learn, other than that, is any others need IE or ISC, Industrial and System Engineering, major student to for the internship?
So I think there's a lot of work that's going on in a lot of disciplines around data analytics and optimization and all those kind of things. So I think that there's probably some opportunities there. I'm not sure if I know of all the particular ones.
Okay.
But you know, a lot of our job postings, when we actually put it, you know, we'll put, you know, requires getting a degree in mechanical, aerospace, nuclear, chemical, industrial, right? Because those degrees now are becoming so, you know, interdisciplinary that we don't necessarily just want to say, well, we're doing structural analysis, we only need a mechanical engineer. That's not necessarily true, right? So yeah, I would encourage your students to look.
Sure. Thank you. Thank you so much. Thank you. Yeah.
All right. I don't see any more hands up.
We have one question in the chat if we have time.
What are some qualities you expect to see in an ideal intern at Sandia? Well, I think someone who's got some passion for the kind of work that we do, and somebody who's got definitely an interest in, you know, some of those foundational disciplines. Although we hire business majors and things like that, you know, we like to see people that are interested in national security and interested in coming and learning new things. Now, depending on whether you apply after your freshman year or after your junior year, that'll obviously tell us what sort of academic knowledge you have, and that'll help us in determining where we can put people. But Sandia is a great place to work, and we just want people who want to come in ready to learn. Let's see, if we obtained a security clearance at the Kansas City, will that translate to Sandia? It should. So even if your clearance was terminated after you left the position at Kansas City, they should be able to reactivate it relatively quickly. It's the same clearance. And then internships are only available for US citizens, right? I believe that is correct. If there are internships available for non-US citizens, it will say it in the job posting.
All right.
That's the nature of the work we do. For the most part, we need to get people with security clearances, and in order to get a clearance, you have to have US citizenship. Okay. So why don't, doesn't look like there's any more questions. So why don't I go to the next presentation where I'm talking about AIAA. If you think of some Sandia questions, you can ask them at the end too. But I'm really glad you guys are asking a lot of questions. Some of the schools I talk to, everybody's very shy, but I can tell that you all are not.
Go Miners.
So I appreciate that. Okay. So as Dr. McDonald mentioned in the intro, I am currently the president of AIAA, and I will tell you that I'm really happy to see that we have an AIAA student section that is at a school that doesn't even have an aerospace program. I know that you all are mostly affiliated with mechanical, and we do have some around the country that are like that, but always happy to see that. And so what I want to talk to you about today in this short presentation is really what AIAA has done for me as a student and as a professional, and why I think it's really, really important that that you all continue in any professional society. I'll put in a plug for AIAA. I was actually a member of ASME too for many years, but why professional societies can be important to you and how they can enable your career. So let's talk a little bit about AIAA. You all probably know a lot about AIAA or you wouldn't be here. For those of you who are currently not members, I encourage you to become a member. It doesn't cost that much. And for those of you who are members, I would encourage you to go get the rest of your colleagues who are students in your classes and get them to think about becoming a member. AIAA is the world's largest professional society, aerospace professional society. We are member driven, so it means that we're governed by a volunteer president, board of directors, and council of directors. There is an AIAA professional staff that actually works in Washington, D.C. and helps us do what we do. You all have probably been in contact with Lindsay Mitchell, who is the manager for the student programs and the region and section programs. She was going to attend tonight, but unfortunately her and her family all got sick this weekend. So luckily not COVID, but she was going to be unable to attend. But hopefully your leadership team has been in touch with her. And so We have over 30,000 members, 8,000 or more of them are students. I think there's probably about 32,000 aerospace or aerospace related students within the country, and I'd like to see all of them become members. And our members join for various different reasons, but we get bent into certain areas, and these areas here are sort of based on your interest areas. So the Aerospace Sciences are sort of your classical aerodynamics and fluid dynamics and heat transfer. Space and Missile Systems actually focus on some of the space architectures. Aerospace design and structures or materials, structural dynamics, solid mechanics. They probably sound like some of the classes you all are taking. Propulsion and energy, pretty self-explanatory. Aircraft and atmospheric systems. So we've got the aeronautics side and the astronautic side, and then there's a lot of work in information systems and autonomy and things like that. And so this one graphic is meant to describe what we as an institute want to be able to do for people. We want to be here when you're a student, even in K through 12 and high school, and then be there for you with products and services throughout your career, including, you know, high school educators, undergraduate and graduate students, and then when you become a professional during the various phases of your career as a young professional, a mid-career or senior professional, and unfortunately I'm getting closer to the senior side, and then ultimately as a retiree. So let's talk a little bit about my story and how AIAA became part of my life. So back in 1978, this was the 75th anniversary of the Wright brothers flight. My dad was a professor at North Carolina State, and he was taking the AIAA student section to go actually see the reenactment of the flight. And so I was 12 years old. You can see me here with my big hair, and he let me tag along to go on that trip. And it was really cool. They tried to reenact the first flight, but they didn't have any luck. I actually later found out that the Wright Flyer, as originally designed, is an unstable aircraft. So it was amazing that the Wright brothers actually got off and flew as far as they did when they did. But there's actually some modifications people have made to replicas of the Wright Flyer to make it more stable. And so after that, you know, I got to go with my dad to attend a lot of the student section meetings and hear a lot of speakers talk about space and airplanes. And I just knew right away that that was for me. I wanted to be an aerospace engineer. So in 1984, I went to North Carolina State as a freshman, and I joined AIAA as a student member, and I haven't looked back. So you all are smart enough to do the math, and you can probably figure out about how old I am. But it's been a while. Becoming a member of AIAA was one of the best decisions for me. And the great thing about the AIAA student section at NC State was all of our activities were sort of under the umbrella of AIAA. So whether it was competing in an Engineers Week, we had AIAA intramural teams for basketball, volleyball, and softball, and football. The Sigma Gamma Tau, which is the Aerospace Engineering Honor Society, all that stuff was handled under AIAA. So they really looked out for us while we were students. And so when I was there, I got to do some really fun things, like my best friend and I founded the NCSU Skydiving Club, and you can see me here in my outfit. This is me landing my parachute at the opening of the AIAA student picnic, where the seniors got to fly their senior design projects. Because of AIAA, I was actually able to get in touch with some people at NASA and do an internship there called the LARS program, where I got to work on trying to reduce drag on fuselages by changing the shape of the boat tail to something that looked kind of like a Hershey's Kiss. That knowledge would help me later in life. Our senior design project was building an airplane. You can see our airplane here. We were all real happy it made it off the ground, but it turns out that as soon as it took off, the plane started doing this number. And this guy here in the background in the light blue shirt and the jeans was actually the pilot, and he was able to get the plane back on the ground. And we actually figured out that our CG was not in the right place, and we didn't check it before the first flight. So I should have remembered the Wright brothers, unstable airplane, check where your CG is. But luckily we fixed it, we shifted some weight around, it flew flawlessly. Now, AIAA was really good for me as a student, but I also had some regrets. So one was I backed out of being an AIAA officer after I said I would. And the reason I regret it is because it probably would have helped me build some leadership skills that I didn't have back in college. I was hoping to present a student paper at the student conference that year, but I really didn't complete the work that I wanted to do that summer, and I just never found the time to finish it on my own. So I didn't get to go to the student conference. And then unfortunately, the AIAA Design Build Fly program, which some of you all may be participating in if you all do that, was not around 25 years ago. And so when we flew our plane as part of our grade, that was it. We were done, senior design. So anyway, I decided to go to graduate school. It was a big time for hypersonics. And up here on the top right is what was called the National Aerospace Plane. So back in the late 80s, there was a program where we were going to build a hypersonic airplane that would take off and land like a regular airplane, but would fly from Washington, D.C. to Tokyo in 2 hours. And I really wanted to get involved with that. So I applied to a lot of different universities for graduate school, but I ultimately decided to stay at NCSU and work for one of my professors that I had in undergrad. And he was working on developing some computer programs that would approximate aerodynamic heating for hypersonic vehicles. Some of this technology was originally developed for the space shuttle, and we wanted to make it applicable to sharper hypersonic vehicles like this. So I got to spend 2 more summers at NASA Langley working with some of the researchers there as well. These are some results of the work I did, and these are basically streamlines that you would get at a hypersonic vehicle at various angles of attack. This is a side view, this is a front view. I actually got to submit a paper to a conference. It was the AIAA Thermophysics Conference in 1990, which took place in Hawaii. But unfortunately, my paper was rejected. I didn't get to go. I was really sad about that, but there's more to this story that I'll bring up later. But I ultimately did get to publish that work in an AIAA conference a year later, and I got to publish my work in an AIAA journal. So, you know, I finished my master's degree and I was published. And that was a really good thing, and AIAA was there for me to do that and help me with the start of my career. And so I decided to go get a PhD, and I was going to go to another school, but then I decided to stay because a professor by the name of Graham Candler, who's now at the University of Minnesota, and I think he was only 3 or 4 years older than me, had just completed his PhD work in computational fluid dynamics, and he was working on the stuff I wanted to work on. So for my PhD research, I actually got to model hypersonic flows using computational fluid dynamics. And the problem I was looking at was trying to understand the reentry of the old Apollo vehicles. So when the Apollo vehicle first flew, the first flight, it ended up landing 200 miles downrange of what they originally predicted using very simple codes and wind tunnels. And they weren't quite sure what happened, but the thing that happens in hypersonic flows is, and this is an example of the Apollo vehicle, and you can see the shock wave, as air passes through a shock wave, it heats up to several thousand degrees Kelvin. And that heating up of the air actually causes the N2 and the O2 molecules to break apart. Because air is made of N2 and O2, but when you heat it up, they actually break apart into N and O. Well, the process of breaking apart those molecules requires energy. Where are you going to get that energy from? Well, it has to come out of the flow. And so the theory that we developed is that the reason that the Apollo vehicle didn't have the aerodynamics they thought it did is because that we weren't taking into account the chemical reactions going on in the flow field. We were just treating the air like a perfect gas. And when you get up to high temperatures, it's not right. And so this simulation here is flow over the Apollo vehicle for a perfect gas, and this is an angle of attack. You can see the shock wave out here. And then this is one considering a reacting gas, and you can actually see that the shock wave's a lot closer to the body because once you take into account these reactions, it's energy out of the flow. And as it turns out, it changes the aerodynamics of these vehicles. So the lift, the drag, the pitching moment all change when you have a reacting flow. And so I was able to prove that with my code and apply the code to these sort of slender looking vehicles, flow going right to left. And these were things that might look like examples of what those hypersonic space planes would look like. So I got to spend 2 more summers at NASA Langley working with some other researchers. I got to publish some more papers and conferences and journal articles and got my PhD. And it was like, wow, you know, I could not have put myself in a better position to work in the hypersonics area. Not only NC State being there for me, but AIAA is a professional society. Then I ended up graduating in '93, but in the early 1990s is when the Cold War ended and a lot of the defense work dried up. In particular, the Berlin Wall fell, the Soviet Union broke apart, the employment in the aerospace industry really started to drop off. That dream job I thought I was going to get at NASA wasn't going to happen. And then at the same time, all that work that I just learned in hypersonics went away. So I was like, well, what am I going to do? Well, luckily I was able to get a postdoc at this place called Sandia National Labs in Albuquerque, New Mexico, where I got to work on a couple of really interesting projects, but they were not hypersonics. And so one was a way to model thermal sprays. And so General Motors had developed a torch-like geometry where you would melt metal and accelerate it at Mach 2, and then have that metal impact on the inside of their cylinder engine boards. And they wanted to spray coat these things rather than putting in cast iron sleeves to make the engines lighter. And so we actually worked with General Motors to simulate this process and help them optimize it for future engines. And so I got to publish some more papers. One was in the or 2 of them in the Thermal Spray Society, and we actually won best papers. But I was also able to continue with AIAA. So even though I wasn't doing hypersonics anymore, AIAA has a fluid dynamics conference, and I was able to present some of that work because it's fluids, it's combustion, it's multi-phase materials. And so that was something that I could do there. And then also we were looking at drag reduction on tractor trailers. So I told you I was looking at drag reduction when I was at NASA as a student, basically doing the same thing here for trucks. And we were looking at these boat tail shapes on this CAD model for trying to increase the base pressure behind these tractor trailers to reduce drag. And so if you drive behind a tractor trailer nowadays, you'll actually see something that looks like these plates that are hanging off the top of the back by the door. And those plates are basically trying to do the same thing of increasing the base pressure. And so I joined the Society of Automotive Engineers. I published a couple of papers there, but because it was aerodynamics work, I was also able to apply it to publishing it at the Applied Aerodynamics Conference, another conference AIAA has. And so that was really great. Now, one of the things that myself and my colleagues learned about me being a computational person is that you probably ought to keep me from doing experimental work, because one day they caught me in the wind tunnel at Texas A&M trying to, ride our wind tunnel model like a bucking bronco. So that was the extent of my experimental work. But I would say the good thing was I did learn a lot about experimental capabilities, because I was actually comparing my simulations to the data. And so the good thing about it here is I got to go to a laboratory where I wasn't necessarily doing what I did my graduate work in, but I was applying those fundamentals that I learned in my classes, the fundamentals of fluid mechanics and heat transfer and structural response and all those kind of things. I mean, they were there, I learned them, I was just now applying them to different problems. And so that was really cool. And so in the late 1990s, hypersonics came back. I got to do some ablation modeling, and this is some of my early work. It doesn't look nearly as impressive as the movie that I showed you, but it was at least the start of it. I got to work on developing some blast wave modeling, where we wanted to understand is what happens to a hypersonic vehicle if it gets hit by a blast wave. It could be generated by a nuclear explosion. I later went into management, and I actually helped support the Columbia accident investigation and have been a reviewer for NASA of their Artemis crew vehicle, which is hopefully going to fly next year. And then I got to be involved in a lot of flight testing work. I showed you this hypersonic vehicle earlier. This one here is actually a different shape where I got to do all the CFD modeling and help develop the aerodynamics model, which was used to design the trajectories for these vehicles. So I got to get back into hypersonics and publish some more papers and things like that. And as I was transitioning into management, AIAA continued to be an organization that I focused on. And so, my story continues. And so, as I mentioned earlier, I got out of school in the summer of 1993. And before I left, I had a mentor from my NASA days who told me, he says, hey, you know what, when you get to Sandia, ask them if you can join an AIAA technical committee. He said it'll be the best decision of your professional life. And I was like, so what is an AIAA technical committee? I don't know what they do. And he said, well, those conferences that you attend and where you presented, they're the volunteer committees of members that actually organize those conferences. So it turns out this guy, David Throckmorton, is here in this picture with the white sweater holding the plaque. And so it turns out he was the same guy who rejected my paper a few years before when I tried to get my first paper published. So I'm not quite sure if he was, trying to make amends for rejecting me or he was feeling sorry, but he was the one person who I think took the interest in me and got me to get involved in AIAA. And so what you see here on this page is a whole list of things that I got involved in. So being on a technical committee, I ultimately chaired not only the committee, but one of the conferences. I became an editor for one of the journals that I had published in. I was a section officer for the Albuquerque section for a few years. I ultimately got elected to the board of directors and held several positions. I did get to go to the Region 4 Student Conference, which hopefully you all will participate in this year and in future years as a judge. So I didn't get to go as a student, but I got to go as a judge. And then recently, in the last couple of years, I was elected president, and I'm about 6 months into my 2-year term. And so there are two things that I tell people that AIAA did for me beyond publishing the papers and things like that. One is all of these positions I was in helped me be a better leader, because I was not leading people who worked for me and I paid their salaries, but they're volunteers. They're members like myself. And this allowed me to become a better leader. That was the one thing. And then probably the next thing, which is the most important thing, is the networking. And there's a lot of pictures here, and I'll talk about some of them, but I have gotten to meet so many people through AIAA that have become my best friends. They've helped me professionally. They're the reasons why I'm on committees. They're reasons why I bring people in to be on committees at Sandia and review boards. And, I've gotten to meet so many people. So we'll just walk around this collage of pictures. So this is actually a picture of me and my dad, who passed away last year. And we were both fellows of AIAA. This is Mike Griffin here. In this picture, he's the former director of NASA, or administrator of NASA, and he also just recently retired as a deputy undersecretary of defense. This is a student I actually recruited for an internship at Sandia, and she ended up winning an AIAA award. This is Buzz Aldrin, the second man to walk on the moon. This is Gwen Shotwell, who is currently the president of SpaceX, and you can see that her company is doing a lot of great things, and then many other friends and colleagues. And so at this point in my career, the two pictures that I'm probably the most proudest of are these two at the bottom. And this is with a recently graduated student who had just begun her professional career, and we met at a speed networking event at one of the AIAA conferences, and I was trying to impart some of my knowledge onto her. And then this next one here is actually me talking to students like yourself at a conference, and they were really interested about AIAA and why was I so involved in it and what could I get out of it. And so, this is where I'm at now in my career, is trying to give back to you all and help you understand how AIAA can help you. So in the few minutes I have left, I just sort of quickly want to go through a few slides talking about AIAA. You all know about student branches because you have one. And like I said, we've got over 8,000 student members, but I'd actually like to see that number go up much higher. So you all are deputized to help me get more students become members of AIAA. not only as student members, but ultimately staying on as a professional member. You get a lot for your membership. So right now we have a $15 a year student member. It's limited times. I think it's going through January, and then the price will go up to $28. But you get access to Aerospace America, which is the monthly magazine. We've got a career center. We hold recruiting events, including holding a lot of virtual ones that you should be seeing in your email or social media. You get discounts on our AIAA conferences, on publications. You actually get a free subscription to Aviation Week, which is probably worth the $15 right there. And we also just recently started a mentor match program. So you should have gotten an email about this, but if you didn't see it, you can actually sign up to be a mentee. I've already signed up to be a mentor, and I've already picked up two mentees that I've been connecting with. There's a lot of programs that are of interest to the university. So we have graduate and undergraduate scholarships that you can apply for. There's the design, build, fly competition. There's design and paper competitions. There's the regional student paper conferences that you all can present and actually meet people and sort of start that networking part of your career. The AIAA Foundation is our arm of the Institute that's actually helping to get donations for our scholarships and our grants and organizing the student conferences and things like that. So, you know, now that I'm getting later in my career, I'm investing in the AIAA Foundation for my charitable contributions, because I want to see you all as students have the same opportunities that I had, even if I didn't take advantage of them back then. You know, when you become a professional member, once you're done with undergrad or graduate school, we try to make it very easy and gradually increase the dues over a period of years. You might look at that $125 and say, wow, that's a lot of money. But given all the things that I've gotten from it, it's worth it. And, you know, you can get involved in the student section where or the local professional section where your job is. You can, again, enhance your leadership skills by volunteering on these committees. You can help support design competitions for students. When I first got to Albuquerque, I actually helped support a design competition at UNM for high school and middle school students. And then as young professionals, we try to give you the opportunities that'll help you grow as a member. So that's that for that presentation. I know I've talked a lot, but I really wanted to share why AIAA has been, you know, really important to me. And let me get back to the unsharing my screen and definitely be open to some more questions.
Go ahead, Arturo.
I saw that in your presentation you had like different nose tips for different vehicles. Does the nose tip changes the aerodynamics of the vehicle?
Yes, it does. Because the shape is changing. So if the shape changes, the pressure distribution that you will get on any type of aerospace vehicle will change, because it's not only a function of the flow field and the Mach number or the incoming velocity, it's a function of the shape. So you want to know what your shape is so you can understand the aerodynamics.
Thanks.
Yeah.
We do have a question in the chat.
Okay. You mentioned of having a dream job at NASA, but received an offer from Sandia. What are some of the projects that have kept you at Sandia rather than pursuing a job at NASA? So I will say I did get a job offer at NASA. It was a postdoc position, but I decided that I wanted to check out this place, Sandia, because it looked like a really great place to go work. I figured I could always go back to NASA if I wanted to. So let's see some of the projects that I've worked on, and I actually have worked with people at NASA. As I mentioned, they actually pay me as a consultant, not a whole lot of money that goes through Sandia. But let's see, I've gotten to work on the thermal spray work, on the tractor trailer drag reduction, on computational techniques for hypersonic vehicles. I got to work on a developing an aero model for a supersonic vehicle. I got to work when I was in management, leading a lot of our research work and also supporting some of our applications work for the DoD. And Sandia just was a place that offered so many different application areas. Like I said, you can be in a different job every few years, but you just end up driving to a different building. You don't have to move. You live in the same house. And so that's a nice thing about Sandia's national security mission. It's just there's a lot of opportunity. But I still get to work with NASA quite a bit. So you can kind of say I partially got that part of the dream job.
Alrighty, thank you. Next, we have a question from Alexander Hillstrom.
Okay.
Hello, greetings from Penn State. I'm a former UTEP grad, so I'm not an imposter.
Okay.
I do understand that AIAA, even though it's US based as it says in the name, is American, but I do know that they work abroad. So what is that relationship like with universities and other international organizations?
Yeah, so I think about 20% of our membership is actually international. And so we do have, folks come from other countries. There are actually sections outside the United States, Canada, Europe, Asia, Australia. We have people who come and participate in our conferences. They participate on our committees. They write papers. They write journal articles, things like that. We actually have some joint conferences sometimes where we're actually putting on a conference with another aerospace society. For example, our Hypersonics conference is usually international every other time, and we'll work with some local agencies as well to put those on. So yeah, we have quite a few people, quite a big international presence within AIAA.
Thank you.
Mm-hmm.
Thanks, Alex. Go ahead, Eric.
Okay, so one thing I wanted to point out, and I saw this in the chat that Jack Chessis mentioned, is that we're getting a program in aerospace and aeronautical engineering starting at UTEP in 2021 with an MS program to follow. And I just wanted to tell all the students that I also posted in the chat the dates and the deadlines for the Region 4 conference, which is in Oklahoma State University in March. I'm guessing that'll be virtual, but still an opportunity to publish and get some ideas out.
Yeah. So right now we are hoping to have it in person, but we're making plans for it to be virtual, just because of what's going on and the uncertainty. And so, yeah, I'd encourage all of you, if you've got something, a research project you've been working on, or something from a past internship, or encourage you. You can do team papers or individual papers, undergraduate, graduate, and they really put on a lot of networking events as well, so you can meet. The local sections usually work with the local student section to put on the conference, so you'll get to meet people who are working in the industry and all that kind of stuff. So I'd encourage you to participate if you can, even if you don't have a paper. And doing that virtually will be much easier.
If anyone is interested in joining AIAA at UTEP, we did put the president's contact information in the chat. His name is Rene Aguilar, so please contact him. Once Dr. Hassan is completely done presenting this evening, Rene will give a short presentation on AIAA at UTEP for those who are interested.
Great. Any other questions?
That was fascinating. It was just a pleasure to hear that, all of it, both Sandia and AIAA as well.
So let's see, there's one last thing that I'll offer to all of you, is to connect with me on LinkedIn. I think I'm the only Basil Hassan from Sandia National Lab, so I should be easy to find. And if you connect with me, just tell me you met me at the UTEP presentation. And if you ever have questions or things that you want to talk to me about, feel free to connect with me. I've looked at people's resumes. People have asked me about places to get internships and all that kind of stuff. And then AIAA will also post a lot of In addition to the emails you'll get, they use LinkedIn, Facebook, Instagram, Twitter, probably some other social media outlets that I don't know about. And usually what I try to do is when things are coming up, I try to share them. So in the recent months, we've actually had a lot of virtual events or seminars where we've had young professionals talk about their career. We've had, I think SpaceX and Lockheed Martin put on some career fairs talking about the kind of work they're doing. So there's a lot of things you can connect with, especially over the holidays when you guys are done with school. There's just a lot of virtual content that you can either connect to live or stream that you will probably find very valuable. So I really do appreciate you all taking the time to meet with me tonight. I know you got a lot of work to do before the end of the semester, but I wish you the best of luck. And I think thank you to Dr. McDonald and to Rene for getting this set up.
Awesome.
Thank you so much for your time, Dr. Hassan.
Okay, great.
Alrighty, so Rene, if you would like to share your screen or any content you may have.
Yes, I'm gonna go ahead and do that right now. I am very excited to be debuting this, especially to the Dr. Hassan. I find it's a very great honor, so I do appreciate that. All right, let me just set this up. Okay.
All right, your screen.
Awesome. So, as was stated several times during Dr. Hassan's presentation, we are, to my knowledge, the only AIAA student chapter within UTEP and El Paso, I may believe. And as we may discuss later, that was almost not going to be, but I'm very glad on the parent organization that we're now a part of. So our formal name is the Revolutionary and Persistent Team of Rocketry Students of UTEP Student Branch of the American Institute of Aeronautics and Astronautics. So if you take that acronym, our team name is Raptors. So UTEP's chapter of AIAA is simply that, UTEP's chapter of the American Institute of Aeronautics and Astronautics. Within that, Raptors is the predominant team, which will be operating under AIAA guidelines, as well as UTEP's local guidelines. And in shorthand and in documents and memos, we reference our team as Raptors and our parent organization as AIAA. Our mission statement, which was agreed upon by me and some of our other officers and members. So Raptors is an aerospace-focused group of engineers under AIAA at the University of Texas at El Paso. Its function serves to educate and inspire the student engineers within its ranks to apply, innovate, and evolve the problem sets encountered during every mission parameter. The definition of mission parameters will come in a moment. Within the compartment of aeronautical and astronautical engineering achievements and all other areas deemed necessary to implement our efforts, we shall never allow anything less than our very best to ourselves and the glorious university in which we reside in. So with that comes our priority as being a part or being a branch of AIAA. So at the beginning, it was very up in the air because Raptors formed first without us ever knowing that there was or with limited knowledge in UTEP's branch of AIAA. And for a second, we were actually going to be a part of SAE. Now, Dr. Hassan mentioned that, and obviously to operate under AIAA, all our members have to be members of the parent organization, the broader AIAA national organization. But unbeknownst to many of us in the Raptors already, for $15, we actually discovered that, as Dr. Hassan mentioned, you really do get a wide variety, or we actually do get a wide variety of resources that they supply all their members, especially their especially their contacts to a wide variety of fellows that they have. So if you guys want to be a part of AIAA, and there's more slides, don't worry, I'm not going to end it right here. But if you guys do want to be a part of UTEP's branch of AIAA, the Raptors team, a modified version of this PowerPoint will be supplied to you. Just email me. My contact information will be put in the chat and later on in this presentation. Just email me, and I will send all the details for how you can become members straight away, so that way we can have full operating status for when our first mission parameter is assigned. On top of that, however, every UTEP organization, including us, which we qualify as an RSO, a renewed student organization, we charge a local UTEP AIAA fee, or technically a Raptors fee, of just $20. Now, the first priority for all members is obviously to become AIAA members first. Later, meetings and announcements will be made on when exactly the $20 for our local UTEP chapter has to be paid. But your first priority should be the AIAA membership. So we operate within the 4th region of AIAA in the United States, at least. And with that comes comes part of a realization. If you look at the AIAA website, we list Albuquerque, we list White Sands, and many other cities like Houston within the 4th region. However, El Paso is not one of the cities. So we hope in the very, very near future to remedy that and help represent AIAA in the El Paso borderland soon. And with our relative close proximity to White Sands Missile Range and Sandia National Laboratories, we can assume that we'll be working, or we might collaborate with them in the future when we see fit. So the internal structure of our team, Raptors, is composed of 8 divisions. Now, aerodynamics and dynamic stability, these are the people mostly charged with, of course, fluid dynamics, determining drag coefficients, and are more than likely going to be the team responsible for producing aerodynamic memos, which we'll get into in a minute. Avionics, these are mainly the individuals concerned with the avionics package that goes in some of our rockets, or will go in some of the aircraft, the light aircraft that we may, light remote controlled aircraft, I should say, that we may engineer. Structure design, mainly truss engineering. Propulsion, self-explanatory. Even experimental types of propulsion, which we may talk about later in this presentation. Trajectory analysis and theoretical calculations, and this is more of the physical, theoretical side of how we can map our mission parameters, like where exactly in space and time can we actually make a real rocket that we are going to measure ourselves and have no other variables predetermined for us. This team will be the main team to find all those answers for us. Financial economics and engineering ethics. So this one, as agreed to by many of the officers, the thought process for this sub-team, was we want to make sure that whatever we do, like let's say if we're going to we're using a type of rocket, or we're using a type of rocket engine, it's like a model rocket engine. This team is responsible for not only handling our financial assets, which mainly those are going to be liquid, because we're going to have to purchase materials to make our rockets and things like that. But also, we want to make sure that we're not, like, wherever we test, it's not going to be somewhere random in the desert, but we want to make sure that wherever we test or experiment, we're not causing undue harm to the environment. We don't want to like outline a procedure to use like a very potent greenhouse gas if there's a better alternative. This team will be responsible for producing those options, however little or however drastic they may be. Systems engineering, everything above, just combine. You know, how can we present this memo and produce papers showing all our progress and work up until that point, and how can we engineer the systems together? That's essentially the purple team. Asset recovery, repair, and refurbishing. So let's say if we run a test, or we're done with a specific competition, if we do want to like dress up the aircraft and or the aerospace vehicle and, like, you know, decorate some of the engineering labs, like maybe hang it from the ceiling, you know, you've seen exhibits like that. This team will be responsible for not only tracking the vehicle while it's mid-flight. I mean, obviously those will all be predetermined, but this team is responsible for tracking it, repairing it if it becomes damaged when it returns, and refurbishing it so that way, you know, we can hang it up like a nice trophy piece within anywhere at the university that will be applicable, with obviously the main components removed. So a question that arose is, what's with all the color themes? So our team logo is this right here. The it's a logo designed by one of our officers. Now, it's encompassed in a white square, and the patches or the decorations that we want to produce for our not only our officers but all our members, we want them to have like specific details on what exactly which team you were a part of, so that it might have a red accent somewhere if you were part of aerodynamics, propulsion. Some parts will be yellow if it's like a yellow patch underneath it. Just small things like that. It's sort of like a cool, quirky way to like recognize that, hey, you're part of this team. That's cool, you know. So that's sort of the reasoning behind that. Also, if we ever come into contact with any files, the like we're talking about physical like manila folder files, if we see like red or orange or white tape on it, or maybe even just accents that exclaim what team it was, we can identify that quickly, and, you know, we can organize it in a much more neat manner. So this is the second part of organization and procedures. Once we wrap up, once we get up to speed again, once the semester comes, and actually start looking into competitions we want to be a part of, things like that, getting involved with the community. These will be our main procedures. So there will be 2 meetings per week. So let's say you're part of the financial, economics, and ethics team. Your subgroup will meet to discuss whatever matters are presented with your sub-team then. Your sub-team will meet like maybe one day, but then we'll have a full design and engineering meeting. So during these two separate meetings, the main goal is to collaborate with each other with as much ideas as we can when we're in like the sub-teams. Then when we come into the main engineering meeting, the entire team, we can see how all these ideas are going to line up, and how we can begin to strategize how we're going to pursue competitions, mission parameters, maybe even design flaws that we're already preemptively searching for. That's what the main team meeting is for. And then we'll also collaborate on maybe even designs, technical drawings, things like that. And this is an idea that was proposed by one of our officers or adapted by one of our officers. The first 15 minutes of both meetings are just going to be devoted to, like, you know, let's say some of you don't exactly feel comfortable with some of the high-end advanced mathematics or physics behind something, or calculus. We want to organize a way how we can sort of, at the very first 15 minutes of each meeting, the officers will get together with ideas, of course, from all the members on what we should present. So if we're like, if we want to strengthen our grasp on statics, so how much weight can a single spar of wood or something hold, or the forces in Cartesian vectors. We'll devote the first 15 minutes of either of these meetings to one of these concepts, and then we'll go over, like, how are we supposed to think about it, how can we solve these, and it's sort of like a refreshing course on academic material, but we want to make sure we're all up to speed on it. Even all the officers, all the members, we're all going to be a part of it. And within these two meetings, our most routine venture, I should say, two things will be produced. So written memos and minutes documents. So written memos, these are mainly just, as they probably already imply, every single meeting between this every single meeting that the sub teams have, so their first individual meeting, they're going to produce a memo that's going to be presented to the wider, they're going to produce a memo that the entire team has access to, so we could just read what they went over, what are they discussing, what's going to happen with some of the designs or technical information they're doing, in supplement to our main engineering meeting. But the written memos, those are going to be posted to our general Teams chat, so we'll have access to all of those. Minutes documents, that's something our secretary will mostly be in charge with, and it's just basically recounting all the events that transpire within the main engineering meeting, or even the sub-team meetings if somebody volunteers. So with that comes a couple of operating goals, which these are straight from the AIAA website on how we can strive to be an effective student branch organization, or student branch team, actually, under the AIAA organization of UTEP. So the first is branch projects and activities. This mainly encompasses, I would say, probably 50 to 75% of what we are going to be doing. Now, some of this stuff we can't, I would say, implement right away, because obviously the pandemic is still raging, and some of these will be harder to do during these circumstances, but nonetheless we will strive to try to abide by these. So the activities and projects, mainly competitions, mission parameters, things that we're going to be computationally working on. And secondly, AIAA Foundation activities. Now, in particular, the design, build, and fly competition, we plan to be a part of very soon at the turn of the year, so 2021. Immediately, progress will start being made on how we can get our foot in the door and how we can compete in those, with obviously the right safety precautions in place. Speakers, I mean, if this whole meeting tonight doesn't answer this for you, well, I don't know what to say. But we obviously appreciate all of our AIAA speakers that have and probably will speak to us in the future, with great acknowledgement and thanks to Dr. Hassan. And as we said, each team will have a like a color theme on, like, sort of what you're doing and what you might be tasked with. So we want to make sure we acknowledge that those students are high value members to our team, as well as our faculty members and our faculty advisors who help us to strive to a better standing on a local, state and even national level. So we want to make sure that in the long-term future, we uphold that nearly above everything, or at the same level as everything else that we do. Secondly, pertaining to our operating goals, outlines are already being made on how we can start approaching schools, like, hey, how can we get students interested in AIAA? What like small, like fun experiments can we show them that will get them interested in the aerospace sector, especially STEM, more importantly, and try to infuse that level of joy from learning with AIAA and just learning in the STEM field as a whole. So outlines are already being made on how to do that. Obviously, schools in El Paso are still in lockdown for the most part. It's not to my knowledge that any schools are actually in person, which would be quite a surprise to me. On top of that, advertising publicity. I've been in talks with several UTEP personnel on how we could do this. This will have more notable information explained later. Fundraising, that will come in a couple of different ways. Predominantly, initially, our main source of funding will come from the student memberships, the local student memberships for UTEP, not the AIAA membership. We don't get anything like that. But our local fundraising techniques will vary, but obviously we don't want to do something that's fishy because we don't want to jeopardize the good name of AIAA or our team or our university as a whole. So there's a lot of things that play there, but I mean, as a whole, UTEP organizations pretty much do well with that. So we're gonna proceed with that once we get around to it. Annual reports. This is possibly, as Dr. Hassan explained, when you can put your work into well-written reports, it really showcases how intuitive like your team may be or how professional you come off on a national stage. We want to make sure that we uphold our Raptors team and our our UTEP AIAA branch well with these. So at the end of each RSO cycle, basically one school year, we're going to produce annual reports on what we did, document and like throw in some some photos that our historian will take, and like, things that we did, even possibly technical information of drawings, designs that we come up with will all be included in our annual report. Now, predominantly for the very near future, we want to be a part of open house events at UTEP. So as many of our officers raised concern about, or not concerned, but commented on, open house events at UTEP are pretty well suited to advertising this organization more. And as a direct consequence of that, membership can come from even just a small amount of interest from people attending these open house events. Now, we're all used to the like in-person open house events, but even on the virtual open houses, like people seem to have like a spark in them whenever they see like cool organizations that are like, hey, you know what, I want to be a part of whatever they're doing, So that's what Raptors will want to achieve when UTEP is inevitably going to host more open house events. Just showcase our organization and, sort of brag.
Hi, Rene. I'm so sorry to interrupt you.
Yes.
I just wanted to say that, yes, we will definitely always support the student org, just like we support and promote all of our student orgs. Hopefully, as the organization grows, they will create more content that we could share with our students. Hopefully, in the spring open house, we would definitely love you all on board so that you can potentially recruit more students. It is 7:35, so I was just going to politely see if you had any final words or any final, information or encouragement for students who'd be interested in joining AIAA, just so that we can, let them There we go. Yep, that's the page we
Yeah.
were looking for.
Yeah.
Thank you, Rene.
I appreciate the kind gesture. So if you guys want any further information on our organization, just make sure you email me. In the subject line, put UTEP AIAA, and just have your name or maybe your ID with, well, maybe not your ID yet, but make sure you just email me, and we'll see to it that you're inaugurated into our organization. So first priority for you guys, if you really do want to be a part of Raptors, make sure you become members of AIAA, and then from there, we'll add you into the group at the team's meetings. With that,
Awesome. Thank you so much, Rene.
of course.
AIAA is reactivated at UTEP thanks to Rene. They were not very active before the semester, so if you all are interested, we do have his email in the chat, so you can just copy and paste it to an email. Just send him a quick message saying you're interested, and we can set you up with your membership. So if anyone doesn't have any further questions, we will close out this session. It is recorded. It should be up on YouTube by the end of the day tomorrow. Our YouTube channel is UTEP Mechanical Engineering. So if no one has any questions, thank you all for the audience. We appreciate all your questions, and have a great evening.
Be safe, guys.
Be safe.
Thank you.